Welcome to the only PHP talk of Next. It's really great to have all you guys here. I am one of the few PHP fanboys at Google, so I want you all to know that this is a safe place. This is a sanctuary. No one's going to make fun of us here. No one's going to make fun of the fact that our language acronym stands for personal homepage. So today, I also have Marek, who is representing Instapage, and Instapage is a San Francisco-based startup that does landing pages. They're, if not the biggest, one of the biggest landing page products out there. And he's going to give us some practical solutions for how they've used PHP with Google Cloud after I'm done with some of the more high-level technical stuff.
Perfect.
So a little bit about me. My name is Brent Schaefer. I do a lot of open source stuff here at Google. So if you've used a PHP client library to access APIs at Google, you've probably used something I've worked on. Also, if you've ever had the extreme misfortune of implementing an OAuth 2 server in PHP, you've probably used my library also. So to illustrate an application's life cycle across Google Cloud Platform, I've built a small app that will take a face image, a base image, and then swap them. So nothing too groundbreaking here, but all this stuff is available on GitHub in case you want to run it. The architecture is a WordPress frontend, just for kicks, and the backend is a Python script that I found on GitHub, and that's been containerized into like a worker type backend. And so this is just supposed to represent like a pretty standard, really basic microservices style setup. I have a clicker, keep forgetting. Okay, so the first thing we're going to do with this application is we're going to run it on Compute Engine. And some of the advantages of Compute Engine is we have this awesome Cloud Launcher product that basically has a bunch of stuff that most PHP developers want to run already set up so that you just click a button. You can configure a couple things like HTTP, HTTPS firewalls. You can add phpMyAdmin, that kind of thing. And we have those for WordPress, LampStack. We have it for Zen Server also. So if you're into that kind of thing, you can run Zen Server, and we handle all of, like the complicated licensing and stuff, and you just pay for it straight through your billing account and stuff. So this is super low barrier entry stuff. I don't know if I can. No, I can't. I was actually going to show you guys my blog, plug my blog, brentertainment.com, because I spun it up using this. It took like 20 minutes. I launched a WordPress instance using Cloud Launcher, and then it was ready to go. So yeah, it's pretty great. One other thing I wanted to mention is they have autoscaling instance groups. So even though it's like super simple stuff, you can actually do pretty complicated scaling rules with it, and then make a pretty resilient application. So this is what you get. This is what my blog is. It's just WordPress running on MySQL in a VM. So does anyone see any problems with this if you wanted to run this like at scale or something? Like, does this seem like it's a sweet solution? We can all go home once we run this. So obviously, like running MySQL on the same instance is not very scalable, right? If you spin up a bunch of these instances, they're all not going to be talking to the same database, and it's not great. So what I've done for this example, and this again took very little time, is I deployed my worker container onto this Compute Engine instance, and then set up WordPress to use Cloud SQL instead of like the MySQL database that's right there on the server. So has anybody used Cloud SQL? Is everyone familiar with this? We just announced today that we support Postgres on Cloud SQL, which is pretty cool. But it's essentially just managed MySQL, and that way you don't have to worry about setting up master-slave replication or requisitioning a big beefy server. We take care of that stuff. All right, so I'm going to demo this real quick, and feel free to follow along on your cell phones if you want to try. The mobile UI is actually really bad. Actually, the UI in general is really bad. I don't think the next branding team is going to be super stoked if they see this. But so it's very simple. let's see, give it a very happy picture of me. And then I have a load of images. Does anybody have anyone in particular they would like to see my face swapped with? I have lots of. This one? All right. These are all like public domain images, of course. That's why I picked them. All right. So this is now calling the Python backend on localhost. And there you go. Look at that. That looks fantastic. All right, sweet. We can go back to the slides. So I'm actually running this architecture, which is just slightly different. What I've done is I've put WordPress into a container that's running on the Compute Engine instance alongside the worker Docker container, and that way they can still communicate through localhost. And what's really great about this is actually really, really scalable. This is a great design. So I can set up autoscaling instance groups through Compute Engine to scale this based on requests per second, things like that, and what else? CPU usage, or you can actually use custom metrics and stuff. But this will now scale to high heavens. And if you really wanted to scale, you could use Spanner instead of Cloud SQL there, and then you're like globally scalable and crazy. But the container part is a significant step, right? You can't just breeze over that. So how many people here are familiar with containers or have built them? Okay, I actually can't see anything with these glasses on, but I think I saw a lot of hands. That's great news. So containers are one of our favorite things here at Google. We absolutely love containers. If you want to know what to get a Googler for Christmas, get him like a gift certificate to the container store or something. He can go and pick out his favorite container. We love these things. We run these everywhere. So to talk more about containers, I think a good introduction is App Engine. So once again, App Engine users. Has anyone here used App Engine? Okay, slightly less, but still a lot of people. So we announced today the GA of App Engine Flex, which is really great. App Engine Flex is similar to App Engine Standard, but we run like standard container format, Docker containers. So you can take pretty much any container and stick it in App Engine. You get all the advantages of App Engine, but you're running your own custom container, which is really sweet. So what we've done, the few PHP-loving Googlers at Google, is we've spent a lot of time building this base image for your PHP applications. And this thing is available on GitHub, and it went into beta this week, or last week. So it's great. And we would love your feedback, obviously, on it, because PHP, as all of you guys know, there's a broad user base with tons of different types of PHP users, and we're trying to come up with a runtime that's really great for everybody. So how does this work? So when you use App Engine, it just copies over your application code, builds it on top of the base PHP image that we've built, and then it deploys the resulting container, right? And this container is built into Google Container Registry, gcr.io. And if you're not familiar with that, it's really basic. It's just like Docker Hub, so it's like a repository for images. Every time you deploy a App Engine app, it gets put into this URL that represents your project ID, the version, and service that you just built. So that's really cool, too, because you can take that image and you could deploy it to Compute Engine or to Amazon or run it locally or to Container Engine, which is what we're going to talk about later. But so some of the advantages of using our base image is we automatically install all of your dependencies if you're using Composer or you have a composer.lock, which you all should be doing. We support all the non-end-of-life versions of PHP, and we'll continue to as new versions come available. We have good logging and error handling integration with Google Cloud products. We're using Nginx, which is great. Apache is also great, and we don't dislike Apache. And in fact, if there was like a public outcry for Apache support, it would be pretty trivial to add it. The problem is it's huge. So it adds like a significant amount of size to the resulting image, which slows down uploading and deployment and stuff like that. Nginx is also great. So we've had a lot of luck with that, and that's what we use in the container. So PHP, any configuration, pretty much everyone's going to have some customization required. So you can enable a set of shared extensions that we've already compiled into the runtime, or you can add whatever custom configuration that you need, and you just drop that ini file in the root of your project, and we load it. And same thing goes with the web server configuration. So with Nginx, if you drop in an nginx-app.conf, we load that configuration and run that for the container. So some security advantages, since secure is in the title of this talk. PHP and your extensions are kept up to date. So like I said, all the supported versions of those extensions, of PHP that we have, when minor releases come out, we keep that regularly up to date. So when you build and deploy your container, you get the latest version. We also have security patches. So a little bit on this, because I think it's a really cool thing that we've done, is how many of you guys have used parse_str or seen that function? Nobody? Oh, wait, this can't be real. This guy over here. Okay, we got one. This is like a really common PHP function. It takes a query string formatted string and splits it apart into key value pairs in an array, right? So if you haven't used it, all the libraries that you're using have used it. So this function is great, but if you don't supply a second argument, instead of loading those variables into an array, it loads them into the current scope that the function is being called in as variables. So you can kind of see why that would be a security issue, right? If you have, a $admin equals false, and then I type $admin equals true, like in the query string, then that variable is going to be overridden. So this is like not good behavior. This is PHP from over 10 years ago, whenever people were doing terrible things with registered globals and stuff like that. So we don't want that. We don't want that at all. This is what we're trying to fight as PHP developers. All those haters, they keep saying that our language isn't secure because of stuff like this. So what we've done in our runtime is we've patched this. So you can't do this. Like, you'll just get an error that you need 2 arguments, which is really good. We also have, for PHP 5.6 only, unfortunately, just for PHP 5.6, because it's not stable for 7.0 and above, we have Sohosen security extension. And this is a really, really good security extension. Currently, what it does for 5.6 is it logs potentially unsafe functions that you might call, like exec and pass through and things like that, and they'll show up in Cloud Logger, so you can kind of like audit your own application code to see how safe it is. But it does additional things too. I know it fixes some, like, it makes sure that none of your C extensions, like the C calls, are doing like improper things with memory, like buffer overflow and stuff like that. So it's good to have that in there. We don't use HT access, which is generally considered not good practice, and we have appropriate file permissions and user permissions for the code that you deploy, so it's not executing as root, and the files aren't writable, stuff like that. Okay, I've talked a lot. So the 2 files that you need, and this actually still isn't like App Engine, this is just a container for your application, which is really nice. The 2 files that you need is php.ini, this one, and this is for whatever PHP configurations you have. For this app in particular, I'm using the GD extension to do some image manipulation. So I've added that to my ini file. I've increased the maximum amount of uploads so that you can upload 100 faces if you want, and it might explode, I don't know, but you can do it. We have a few other extensions that are installed for WordPress, BCMath, and Opcache. So we also have the Nginx configuration file, and this is all that's required for WordPress. And you actually don't need this if you're using our default configuration, but I assume that most people want to add this anyway. But this basically just points to the front controller. So all modern frameworks these days use front controllers. So that's essentially all this is used for. And then for WordPress, you have a special rewrite for WP admin. So if you're deploying to App Engine Flex now, you need one additional file, which is app.yaml. And if you've used App Engine, you've used app.yaml before. This is basically just a configuration file that tells App Engine how to deploy your application. So in this case, we have runtime PHP, to let it know it needs to build from our PHP base image. And we have mflex to deploy to App Engine flexible environment. The runtime configuration thing just says our front controller is in the root of our project. So if you had Symfony, it'd be document root web. If you had Laravel, it'd be document root public. And then the rest of this isn't super important, but you can set environment variables in app.yaml, and if you're using Cloud SQL version 2, you declare your connection there. And it looks like this. This is basically the same as what we have, but now we have 2 separate services instead of 2 services contained in an instance. So some advantages of App Engine. We have versioning with containers and URLs, which is really nice. So every time you deploy, you get a timestamped version for the image and and a URL as well, representing that version that you deployed. We have autoscaling, of course, and you have default SSL on appspot.com, which is nice. So let's go back to the demo. Now here's face swap on App Engine. Oops. Okay, is there anyone else you guys want to see? If not, I'm gonna choose. Okay, I'm gonna go with Ronald Reagan. This one's really good because I apparently look exactly like Ronald Reagan. Face swapping has no effect. So if we look at App Engine in Pantheon here, you see we have a default service, which is our WordPress container, and then a worker, which is the Python service. So I don't know how interactive this crowd is, but if you guys all want to access this on your phones and start actually face swapping with it from images from your phones, we can actually see these scale up, and that's pretty fun. So I would love it if you guys did that. I actually haven't done this before, so I think it'd be kind of fun. But if you go to the URL was gae.faceswap, like 2 P's, FACESWAPP.com. Then that will load this up. You could also go to cloud-next-php.appspot.com and just redirects. And in the meantime, I'm going to upload a couple more. Okay, let's see if this works. Yeah, that's a terrible one. I should delete that. Depending on how many people are doing this might not work. So, is anybody actually face swapping out there? I'm just curious. Raise your hand if you are. Okay, we got 1, 2. I got a handful of people. Okay, so this should definitely work. Should definitely work. Let me do this again. Yeah, when I tested this, it only took like 2 different attempts overloading the worker. I sent in 20, and within seconds it spun up 5 more. So I'm hoping the same thing happens now. Come on. Yeah, okay, we got another one. Sweet. All right, so that's App Engine. It's basic. All right, let's go back to the slides. Okay, so we're going to talk about Container Engine now. So moving an application to Container Engine, now that you've done all these other things, is hilariously easy. I mean, there's not even really a step. You could literally take the image that App Engine uses and deploy it to Container Engine, and you're ready to go. So, it's really simple. One of the cool features, though, that we have is, let's say you do have like a complicated app.yaml or something, you can generate a Dockerfile that represents the container that App Engine builds just with a single gcloud command. And that's gcloud app genconfig -- custom. And so that gets you a Dockerfile. I haven't really explained what a Dockerfile is yet, so that is essentially the standard Docker container format for building your container, and I'll show you an example of that in the next slide. So after you've done that, you run a Docker command to build the Docker image, and then a gcloud command to upload that image to Google Container Registry, which again is like Docker Hub. It's just a repository for all of your container images. So this is what you need. For this app in particular, you need a configuration file for the two different services, our WordPress app and our Worker app, and then you need a configuration file that just basically, this just establishes a load balancer, so you get an IP for your service. This is what a Dockerfile looks like. This is the one I use in this app. It's incredibly basic. All it does is say, we're using the PHP base image, the Google App Engine PHP base image. So there it is. And then your application is going to be installed in the app directory. That's what got generated. These service files, so these are taken by Kubernetes, and Kubernetes is container orchestration. So in comparison with what we did in Container Engine, where we had, what we did in Compute Engine, what we had was just two containers running on the VM. With Kubernetes, we're now going to have like a fleet of these containers that we can scale up and scale down individually. We have a lot more control and management with them, and I'll demonstrate that later. But this is the big value add of using Container Engine. So this configuration file is actually really simple. It may look daunting, but really all we're doing is adding some arbitrary labels here so we can have finer grained control over these containers. And then we have the name of let's see. Yeah, we're just letting it know that we need a load balancer for our WordPress service. So this is a WordPress configuration. You'll see we have a image path using gcr.io, so that it always pulls the latest image. And we let it know we're running in the container, running on port 8080, and we, again, give it some labels so it knows how to reference this container later. And we also have 3 of them going on. This is our worker. It looks pretty much identical. We have a different image path, different labels for it, and we're going to use 2 of those. So I already showed you guys how to build. This is the same thing whenever you deploy these things. You run kubectl apply, and kubectl actually is already on your machine if you use gcloud, and I assume everyone here uses gcloud, so it's already there. You could just run this command, and you're going to deploy these pods to Container Engine. The architecture of this looks pretty much identical to what we had before. Now we just have Container Engine pods instead of App Engine instances. And the difference here is pod is basically just like this conceptual, it's one level of abstraction above the Compute Engine instances that you're running on. And this just allows you to have multiple containers running in pods, and then you can take multiple pods and run them across your instances, your Compute Engine instances. So demo time, once again. All right. This time, I'm going to do my other favorite, which is Jack Nicholson from The Shining. So he looks really angry, but come on, now he's happy. So actually, I think that one's probably scarier than his other face. So to highlight how powerful Kubernetes is, I'm just going to switch to the terminal real quickly and edit the one file that I showed you up there for the worker. And we can see we have 2 replicas right down here. Everybody see that? So I'm going to add a 0 and then just run that same command that I did before, kubectl apply. Now if I do get pods, oops, I got to do it quick. They're already up. That wasn't good because you You guys didn't actually see that they weren't up before. Hold on, let me. Yeah. This one?
Yes, and what means below ready 2/2?
Yeah, okay, good question. So this is a list of the pods, and inside ready is the containers. So 2 of 2 containers are ready. So for our face swap worker pod, we have just one container running, and that's the face swap script. For our WordPress worker, or our WordPress pods, we have 2 containers inside. One is for the actual face swap WordPress container that we built and deployed that I talked about, and one is something that I didn't talk about because I didn't want to confuse anybody, but it's not that confusing. So there's a Cloud SQL proxy running in another container, this Cloud SQL proxy. I can actually show you let's see, go back here. So if we look at this original file that I had, after this container configuration, I have another container configuration that basically spins up from another container image, a proxy server. So the WordPress instance is communicating with a proxy server, which communicates to Cloud SQL. And that's how Cloud SQL version 2 works. I don't know if anybody here that works at Google has a good explanation for why that is. I don't actually know. But if you use something like Spanner, which is something we announced recently, and it's an awesome database, you won't need to do that. You'll just connect directly to it. So yeah, but that's good because it kind of illustrates some of the nuances of Kubernetes that you don't have to deal with if you use App Engine. If you use App Engine, you don't need to spin up a Cloud SQL proxy. The App Engine environment handles that for you. Just connect to the database directly. And it also illustrates how pods contain multiple containers, and then they communicate. The containers can communicate on localhost within the ports, which is really nice. Okay, so what I was going to do, I just want to do this real quickly because I just love how seamless this is. So I just spun it back down to 2. I mean, it happens so fast. Oops, not that. Let's do 30. What the heck? I haven't done that yet. I don't know if that'll work. Okay, there we go. So we already have most of them running, looks like. Yeah. Sweet. So for my final trick, let's just blast this thing with all of these images and see what happens. Come on, come on. Oh, man. Okay, they're coming in. That's good. It's actually a little slower than I expected it, but. Great. So I really like the acquire currency guy up here. I think they all actually look better. I really like the statue of David. That one's nice. I like his build. It's a little better than my own. Okay, so let's go back to the slides. So we talked about Google Compute Engine, which is less managed, but it's the incredible low barrier of entry, and it actually has the ability to be very scalable. And in just 1 second, Mark is going to come up and talk about how they've built a global and very scalable application using that paradigm that I showed you with containers running inside a Compute Engine instance. We've talked about Google App Engine, which is a lot more managed. It's highly scalable. And we've talked about Google Container Engine, which is a little bit maybe higher of a barrier of entry, but once you get used to it, you have an insane amount of options. You can deploy tons of services, manage them very easily. So are there any questions? Sorry, we have Q&A at the end, and we're going to do all the questions then. But is anybody like confused before I hand it over to Mark? Or does this all make sense? OK, sweet. Yeah, we'll be back for questions in just a minute. So without further ado, come on. Oh, and please applaud Mark. He's great.
Yes, thank you. Hello, everyone. I'm quite confused why I was invited, because we use Amazon AWS. No, just kidding. Sure, we have plenty of nice experience with Google Cloud Platform. We moved to Google Cloud Platform in January 2016, and it took over 3 months to learn and evaluate various products, Google Cloud products, against our application. Oh, what I did? Right. Pardon? OK, and before I start, I will give you a quick background about Instapage and me. I am chief architect in Instapage, and I joined Instapage 6 years ago. And since very beginning, I've seen grow from the start to the end. And Instapage is the most powerful landing page marketing solution, and it requires solid infrastructure. Our application seems to be scalable, but not in the right way. And speaking to my colleagues, I had a metaphor that we have a fleet of buses, 40 seats and 1 wheelchair space each one. And we thought we have a capacity to scale. But when we have a spike in need of wheelchair spaces, we are not efficient. Because, for example, we have to send 10 buses for 10 people, which require wheelchair space. And referring to our application, which situation was exactly like that, we needed something more flexible. Because if all traffic came to our monolithic app and there were some bottlenecks, entire application crashed, caused downtime. And after experiments with Kubernetes and Docker, it was clear that orchestration is the right direction. To our system to scale, we decided to chop it and split it into small independent microservices, but gradually. First, we took out analytics storage system, which you can see on the right, and then we made a landing page server system for our clients' landing pages. And as you see on this diagram, after transition, our core-application was smaller. The database was smaller too, and it had to handle less traffic. And most of our traffic was directed to lightweight, dedicated, and auto-scaled microservices. And serving landing pages, we observed that changes in load was very variable and unpredictable. And even we had a lot of spike loads. So we needed some kind of sophisticated automated system that could scale up and scale down. So what we designed was something like reverse proxy. We made it and wrapped into Docker to easy to start them. Because the start time was very crucial, we even created instance template with preloaded Docker image to spawn them as fast as is possible. And then everything we combined in backend services with autoscale turned on. And all traffic is going through the HTTP load balancer, which allows us to direct traffic directly to zone where visitor is from. So visitors from US will see the content generated by instances in US, from Europe in Europe, and from Asia to Asia. And that was perfect solution for our needs. Right, and each instance has been tested to and proved that it can handle 200 requests per second. And with minimum of 5, because we have like 5 zones, 3 in US, 1 in Europe, and 1 in Asia, we could handle 1,000 requests per second. And if traffic exceeds is more than 150 requests per second for any instance, the system created new ones to handle the traffic. And if traffic was going down, system was taking down not needed instances. And real-life traffic, which looks like sometimes like that. Some customers inform us they do expect high load, but some do not. And even if with traffic like that and autoscale system using autoscale backends and Docker, we are able to handle this kind of traffic without human input. The scale, it could be a day. It could be a day. Normal, it looks like a day sometimes.
Quick question for you, Merrick.
Sure.
What's the upper bounds on that graph there?
Which one?
The upper bounds. So it's just, you have 1,000 requests per second, and then it goes up to...
Yes. I do predict that some people creates a campaign using AdWords, and they tend to stop it for some reason, or their ads are running out, or for some reason the traffic drops and then comes up if their campaign is resumed or something like that. Right, and our system has to handle 500,000 registered users who made 1.5 million pages, and traffic to these pages generates 20 to 50 requests per second just normally. When you see the smallest usage, but the high record we recorded was 12,000 requests per second, and even over that time, system was fully functional because it created 60 instances. That was obviously DDoS combined with genuine traffic, but we had to handle it at least for the beginning. And we have done like great work, and we have more efficiency and scalability, and much more stable platform, and we are ready to grow even more. Thank you.
So while you're up here, I have a quick question. So sure. You said you have 6 microservices plus WordPress front end plus a PHP back end that is gradually being split.
Exactly. The diagram I showed you on the beginning is like nothing what we have like in real. Yes, we have like now we have our core PHP application, WordPress, and 4 microservices, because I count PHP as.
And you have all those are all containerized, and they're running in on a single compute engine instance.
Exactly. And yes, and thank you. You told that because we do containerize everything because we want to use Kubernetes to manage our deployments, and just to manage it.
So a follow-up question then would be, of course, it seems like it's a good fit for a Kubernetes deployment. So I'm curious why you guys made the decision to use Docker and Compute Engine as opposed to going with Container Engine.
Yes, that was why we are containerizing everything.
Gotcha. Yeah, so I really like your guys' story. I think it's really cool because it kind of shows where a lot of PHP applications are, right? You start with, I have personally been involved with many PHP applications that follow this trend of starting with a massive monolithic application that was built a while ago, and it's being split off because it no longer scales well or just because it's very hard to manage. So you guys are kind of in between where you have moved away from the monolithic PHP app stage, but you're still transitioning to the fully orchestrated via Kubernetes / container engine fleet of containers. So, it's obviously a long process to move an application to that. You mentioned that you guys have 4 or 5 other microservices that you're
in development, yes.
That are in development, yeah, and that you guys are going to deploy pretty soon. So at that point, you're looking at a very strong use case for something like Kubernetes because you're not going to have those services those services are not going to scale equally, right? You're going to want to scale some more than others and everything else. One of the advantages of Kubernetes I also wanted to highlight and using container orchestration in general is whenever you're pushing updates and rolling updates for this stuff like I did, which was in a very, very small scale, but when you're talking about a very big scale, like Mark is doing, you can use the tags and the labels. You can do rolling updates. Kubernetes actually has support for just doing rolling updates, so it'll take down half your pods and deploy the new pods pretty much transparently. But another advantage is if you have coupling between these microservices where, let's say, you have an interface that's going to break compatibility, and so the way that these two microservices talk to each other has to be updated at the same time. Kubernetes makes it very easy to do that as well using those labels. So as long as you have the proper labels, you can roll over those services together. So I'm personally not a DevOps guy, which is probably why I absolutely love containerization in general, and then also even more so Kubernetes and Container Engine, because it makes me the DevOps guy. Like I don't do the bash scripts. At every other job I've worked at, I turn over the application code to these guys that are building RPMs and they live inside their terminal and they're super fast typers and have all these hotkeys, and that's not me. But this kind of stuff makes that very accessible, and it makes you feel like you are, you do have good oversight to your DevOps. So actually, because we have extra time, I'd like to turn it back over to my demo real quick and show one other thing. So you guys already saw the fleet of containers that we deployed on the command line. So if you're using Container Engine, let's see, we have this great little dashboard that you can run. What? Oh, I messed up. And this helps you visualize your cluster. Oops, let's see. Oh, man. Oh, thanks, guys. There she is. So the reason why this is indicating a warning is because I spun up too many. So I spun up 30, but I only have 4 Compute Engine instances that are available. So there's a handful of these pods that couldn't be deployed because they have a minimum amount of requirements that can't be met. So whether it's CPU requirements or something else. Yeah, so this is CPU requirements. So one of the primary tenets of Kubernetes is that it abstracts your container orchestration from the hardware that it runs on or the VMs that it runs on. So the scaling of the pods happens automatically, and it happens separately from the VMs that you give Kubernetes, because Kubernetes is going to take care of all that. It's going to make sure that it schedules the pods in the right places, in the best places. So in this case, if I gave it, a super beefy VM, and then I gave it a one CPU horrible old VM, it's going to use that if it can for resources that it can and make the best of it. So that's pretty much it. Kubernetes it does get very complicated. I think one of the things I wanted to show in this presentation is that it doesn't have to be. There's a lot of really, really good resources out there on Kubernetes. And so I don't need to be another one. There's a Udacity course online on Kubernetes that's great. There's a lot of YouTube videos and presentations that have happened at other Google conferences that are great. But hopefully, you guys get the feeling that you can take an existing PHP application or whichever one that you're planning to build next and give this a try. Give containers a chance because they're great. And Kubernetes itself can be a little bit intimidating at first because you do have these configuration files and stuff, which is why App Engine is great, right? You just gcloud app deploy, your containers are running in the cloud. It's a good way to dip your toe in. And then when you're ready for the next step, you can go ahead and pull those containers down and start running a whole fleet of these things. And that's pretty fun.